Good evening, everyone. My team is Alejandro Pulido, Eduardo Mojica, and Marcela Tarapuez. And today we are going to talk about two articles. The first is about quarantine consideration written by Andes University, and the second is to remove thallium for the wastewater using a combination of persulfate oxidation and coagulation of iron, published in the section of Process Safety and Environmental Protection of Elsevier magazine.
The article created by Mr. Juan Cordobes, Mauricio Santos, Carlos Bravo, and Jaime Castante is about post-quarantine criticisms. The model proposed in the article combines agent modeling and stochastic differential equations, which are used to model various phenomena. In this case, it uses the modeling of COVID-19 to answer the question of whether prolonging quarantine is the solution to the problem, and establishing the effect that mitigation measures can have on the spread of COVID-19 in Bogotá.
To carry out the above, a mathematical model was built to study the dynamics of contagion in realistic urban environment and 5 different alternatives were evaluated, such as the effects of restriction of the mobilization of people, the effects of extending the duration of the restriction in different periods of time, complemented the school closing of restrictive measures for other adults. In order to understand the progress of the epidemic, the evolution of infection, the rate of hospitalization and death through the inclusion of elements of the city's infrastructure such as where people live, workplace, schools, hospitals, among others for assumption.
The different models for the five alternatives were evaluated and the results were analyzed, where it is generally observed that the effect of restricting mobility to different proportions of the population is reflected on the number of infected, since these alternatives to slow down the rate of infection relate restriction to time, mobility, and bed availability in the intensive care unit. Mitigation measures allow the exponential growth of infections to be postponed, but it is not avoided that the ICU's bed capacity is exceeded. The longer the restriction on the mobilization and closure of schools and universities apace the case curve, but it is postponed the time of demand in health services. This measure is more efficient than the immobilization of older adults. However, the model has limitations in that the information in Colombia is not influential in estimating these rates. Additionally, it is not being taken into account other activities such as transport, which increases the possibility of contagion. Okay, the second article is removal of thallium from wastewater by a combination of persulfate oxidation and iron coagulation. In the picture, you can see wastewater treatment for pollution control. Okay, thallium characteristics in wastewater. Thallium is a rare heavy metal with high toxicity and is highly accumulative in the human body and other living organisms. It is difficult removal in wastewater treatment. Health effects. Thallium is a rare heavy metal with high toxicity. It can damage the human nervous system and cause serious health problems. The lethal dose of thallium is only 10 to 15 kilograms for humans. Due to its weak absorbing ability to the surface of many materials, thallium removal with water is more difficult compared to other heavy metals such as lead, cadmium, and arsenic.
Thallium in water exists in two oxidation states, Tl1 and Tl3. Tl1 is very similar to potassium K+ in terms of chemical properties and shows good mobility and stability in water. Tl3 has strong oxidability and its chemical properties resemble those of aluminum Al3+. It tends to be hydrolyzed and is prone to form thallium oxide 3 precipitates when strong. Source of the contamination. In recent decades, the risk of thallium contamination in water bodies has increased dramatically due to industrial activities such as mining, metallurgy, and coal burning. Thallium removal methods in wastewater. Currently, commonly used techniques for thallium removal include ion exchange, adsorption, solvent extraction, and oxidation combined with precipitation.
Thallium removal. The use of strong oxidants to oxidize thallium-1 to thallium-3 and onward to the precipitates of thallium oxide, combined with coagulant to accelerate sedimation, is an effective approach for thallium removal. The method of achievement an effluent thallium concentration of 120 mg per liter when the effluent thallium concentration was as high as 100 to 500 mg per liter. The combination of strong oxidants and iron coagulant are an effective means for thallium removal. Conclusions. Thallium is mainly removed by iron oxidase via coagulation, surface completions, and electrostatic attraction under alkaline conditions. Thallium-1 is oxidized to thallium-3 white, peroxide sulfate, hydroxide ions, and sulfate ions to form thallium oxidase 3 precipitates, which also contribute to thallium removal.